and welcome. I'm Isabel Parra from the Resilient Cities Network, and it is a pleasure to be hosting today this Cities on the Frontline session. We've heard over the years since we started the Cities on the Frontline series from inspiring voices across the region, sector, and many different backgrounds since we launched it with the World Bank on 2020. And I'm really happy today that the conversation is quite timely and has a powerful question to answer, which is, can cities harness the power of artificial intelligence to truly serve the public good? So I don't know if you're an enthusiast like me or if you are a bit on the cautious side, but wherever you are, we are definitely living on a time where computer intelligence is moving fast. And we're already seeing the impact in your day-to-day, in your job, and how it's also transforming industries. And our cities and cities around the world are in the center of this transformation. Local governments are now being called and asked to make decisions that will influence the way we relate with communities, how communities live, how services are delivered, and how fair and inclusive systems become or not. So today, to have this conversation, I have three amazing speakers with me. We have Somesh Sharma from the Institute of Housing and Urban Development, studies at the Erasmus University, Rotterdam. He will set the scene, looking at how AI is being used in cities, what it means for governance, and where are the challenges that cities are facing. Then we will follow with Damiano Cerrone, and he's the co-founder of UrbanistAI. He will share how participatory AI is opening up spaces for debate, for collective imagination and creation, and how it's enabling communities to co-create with local governments and other stakeholders, the streets where they live and the public spaces they visit. And we will then close with Professor Dr. Oelmann from Ruhr West State University of Applied Sciences. And he'll show us how AI is helping municipalities forecast and manage water services. And I think beyond water, his lessons really go beyond and further to other sectors where cities can learn. So before we jump into the conversation, we have some small ground rules. So first, we really hope that we can have an open and candid conversation. That's why we have the Q&A box that you will see in your screen. In there, you can interact and ask the questions to the speakers along the session. We also want to encourage you. I know some of you are already doing it, but if you can say hello and introduce yourself in the chat, that would be really helpful. And do take into account that this session is being recorded, which will allow you to then find the recording and share it with your colleagues or acquaintances by accessing it to our in our website afterwards. So let's get started. Huh? Somesh, can you help us set up the scene and tell us a bit about the fundamentals of AI in cities? Thank you.
Thank you. Thank you very much, Isa. Thank you very much. I'll share my screen and then I will ask you for a confirmation that everything is okay here. Do you see my screen?
Yes, but it's not in presentation mode yet.
Now it's in presentation mode? Perfect. The second thing I'm going to do is to start my timer. Time never stops and never comes back. Let's stick to it. So yes, so thank you very much, Resilient Cities Network, for giving me this chance. Thank you very much, everyone, for joining this webinar series. I'm very pleased to have this opportunity to be able to share my thoughts and ideas with you through this webinar. And my thoughts and ideas, by that I mean what I'm learning in my research What does it mean? It's always a pleasure to share it with others and to know from them what do they think about it. So I'm coming from social sciences background. My research and my passion, my interest is in knowing the interaction between artificial intelligence, or say intelligent machines, and the humans. I'm really interested in it. So during my research, I faced many questions. People asked me those questions, and I kept answering these questions, and that's how I learned few things about artificial intelligence. And I always try to put it from the perspective of society, because that's what it is meant for as we are designing it. So what I'm going to do here in this this talk, this small talk, is to share some of my findings, my opinions. These are like my thoughts in four components. And in every four components, I will try to answer one of the questions. And these questions sound very obvious, but when these questions were asked to me, I really had a hard time to give a convincing answer. But now I have gone through it, and sometimes you really do not have a perfect answer to a very simple and obviously sounding question. And that is our question number one. And when I was asked, okay, what is artificial intelligence and how does it work, when I started my research on AI in a social sciences institute, nothing technical. And then I responded, oh, a machine which acts intelligent. And then there was another question, what is intelligent? And somebody said, okay, that means, then I gave an example that, okay, if somebody can solve problems very fast, much faster than humans, that's intelligence. So they said, is calculator artificial intelligence? And then I had no answer. So the answer is no, calculator is not artificially intelligent. It's programmed. So I had to go through this process. And what I learned about artificial intelligence, it is always reflecting the level of automation. So we are automating machines. So it is evolving. We are not going into the evolution of artificial intelligence, because what is interesting for us is to know what is artificial intelligence of today and where is it taking us in future. So it evolves. So I would say a few decades ago, what was artificial intelligence is now just automation, right? So what was programmed is now an automatic machine. We'll come to some more examples, but it's very important to have a common understanding of what are we going to talk about during our 3 sessions. So we should know what it actually is. So coming to the point of today, now one finding I would like to share, I have stopped working hard to find an objective definition of artificial intelligence, because I learned there is also no objective definition of intelligence. So, but what I can say, that artificially simulating intelligence is artificial intelligence. So it's a science, artificial intelligence, with which we try to simulate human behavior, and not always human behavior, but also biomimicry is a field where we simulate behavior of other living beings. So to make a common understanding, so if we do some science with computers, I'm just bringing it in very simple terms, but it's not wrong. So we write some algorithms, we use some data, we apply some models, and this whole IT system simulates human behavior. For example, we see, let this little guy keep running in the background. I'm not playing the video. We have heard about during COVID, there was this Boston Dynamic machines, robots. They were installed in the parks for maintaining the social distance. So how does this work? So this machine, which looks and walks like a dog, it gives us the feeling of a dog, like kind of. It has sensors. It would sense and compute the distance between two people. If the distance is less than 1.2 meters or whatever is the norm, it will issue a warning. And this is automatic in the machine. This is automated, this is programmed, but this is still artificial intelligence. So there are different levels in artificial intelligence. In some AI, one, you can imagine artificial intelligence as a software, right? It's not a program, it's a set of algorithm, data, and models, right? So this is something in the computer, and this is where it thinks. It thinks just like us. Going back to the previous slide, you would see a very generalized illustration of neural networks, where the pink is the input layer, then blue is the hidden layer, and then the next is the output layer. What's important for us to know is if you have come across, sometimes you log into a website and then they say, no, you first click on the cat and then you click on the ear of the cat and the tail of the cat and then bicycle. So we identify objects. That is where we are training the artificial intelligence. So artificial intelligence of today would recognize objects from the image. So it is learning like humans also learn. There is still a difference. The difference is artificial intelligence has narrow intelligence. We do not yet have general intelligence. By general intelligence, it means whatever we train the AI for, if we have trained AI for a cat, it will recognize only a cat, and it will be able to predict behavior of the cat, but it will get confused when it's a lion, right? Humans can say, okay, now this looks like cat, but this is a lion. So we do still have edge over artificial intelligence. I will conclude this first point here. What is artificial intelligence and how does it work? So in conclusion, I would say it's a science with the help of IT, which helps us simulate human behavior. So the program will give decision, and if you put this program into a machine, the machine will act physically, but that machine is not artificial intelligence, that is a robo. The artificial intelligence is the mind of the robot. So this is artificial intelligence. Second important point to remember, that we are now artificial intelligence learn on its own from the input data, and it predicts on its own through these hidden layers, right? Okay, so then coming to the next part of our discussion, where is artificial intelligence in cities, which is the key portion for our today's webinar. So you see, when we were talking about data in our city, we put sensors on the infrastructure, right? So here I've shown on the left-hand side, our left-hand side and right of the screen, we have roads, we have buildings, we have trees, we have gardens. So imagine you are putting sensors on every physical infrastructure conventionally. Sensors collect data like what is the temperature, what is humidity, how many people are moving, what is the congestion. That data goes into a cloud where there are computations happening. And then this comes to our app. So in my app, I would see, okay, in next 10 minutes, it is going to rain. So I'm not saying this is artificial intelligence, but this is smart city. So our infrastructure gets equipped with the sensors. Sensors collect data. Data goes into the cloud. And from there, it is processed in our application. So we are now all very much connected to digital world. And within these computations, at many places, there are computations done with the help of artificial intelligence, like in our phones, like recommendations in Netflix, like even now ChatGPT. So again, what we remember from this slide is that we are a lot exposed to artificial intelligence through getting into the digital way of living. There are benefits of it, and that's why there are significant benefits of it, but there are also concerns. In very quickly, I will just list the concerns and benefits, because we are going to cover benefits and concerns of AI in our next two discussions with Mark and Damiano. The governance issue with this setup of where city is collecting everything digitally, why? One is the transparency, because the hidden layer of AI, it's not explainable. So how a decision AI has taken, we don't explain. Accountability, because we cannot explain if any fault occurs, who's responsible, there is a question. Bias is, of course, when I write an algorithm, the way I look at the things, algorithm is going to look at the things from my perspective. But at this moment, my opinion is limited to me, myself. But when it goes to AI, it goes up to the impact, goes up to the every user. And as well participation, because in some of the governments are already calculating social score, which is AI-based calculation, your data on which websites you watch, where do you go, how do you respond, your social profile is taken from whenever you log in, and then you get a score, and then based on the score, decisions are taken whether you will get a loan or not. So it may exclude people due to an error in the algorithms. So, but there are many, many, many benefits of artificial intelligence. It helps us do the things that we cannot do. Starts with being able to calculate as fast as we can. So, higher production, precision. Think about ourselves that we would like to repeat the same thing again and again. There's a big agricultural field, and no, even simpler, I would like to park my car in a very narrow space. It's really difficult for me, but if my car is automated, it parks with precision in one go, but I'm subject to the errors of the software. So there are benefits, but there are concerns. Because of the concerns, I think I have 1 minute remaining. I would go towards the conclusion. There are several concerns we hear about, and I would really welcome if you come up with your questions and ideas during the QA session. But I would like to pass on my biggest concern about using AI in everyday life, and that is the importance of human being. The AI which we use now has a consequence, and the consequence is that it's replacing humans, which has always happened. Look historically, before industrial age, there was value for the muscle power. Those who were powerful were getting the jobs. Then came machine, muscle power no more important, but brain power important. Now AI is taking the brain. So again, the brain power is taken by AI, no more important for humans. So now, of course, in one way, in short term, there is job loss, but it is not actually job loss. It is a different skill set needed. But we will adopt to the skill set. So now, I mean, earlier programmers were needed. Now, who is going to get the job in IT? Those who can communicate clearly, because now you only prompt and ChatGPT does the job. So you don't need programming, you need communication. That's a very different skill. We can develop skills, but losing the importance of human being, that's very critical. My last point, why I am concerned about it, is that why do humans make contact with humans? This is coming from sociology background. We make contact with other humans only because we would like to fulfill our needs with exchange, right? When you get time, look into Maslow's hierarchy of needs: safety, security, affection, esteem. So we fulfill our needs with humans. That is the fundamental of basis of society. We need each other. We depend on each other. What if my needs are now being supplied by those machines who are able to mimic humans? And then humans not only make relations, we also break relations. And we break relations because of the ego. I want him to do it this way. He doesn't do it this way. So no, it doesn't work between us, and we break the relation. So now we are making some kind of artificial mimics. They work like humans, so they will give us our needs, but they will not fight like humans because they do not have ego. So there I see a concern towards our fundamental fabric of society, that humans need our fulfilled without interacting with other humans, so we don't give them importance anymore, our societies will become different hybrid societies. So my final message and final conclusion on ethical concerns of AI, which is my subject, is that adopt AI, but with adopting AI, make sure if you can, your adoption of AI is not resulting into reducing reliance on the role of humans, be it at an organizational level or country level or in the personal life. Then we can probably preserve our ethics of today. I'm saying it, but I do believe we may need a new ethical structure for our hybrid societies tomorrow, because we might not only work, we might walk hand to hand with the artificial machines. So Isa, thank you very much. I think my 10 minutes are over.
Yes.
I look forward to response and questions from the audience in the QA round.
Thank you so much. That was a really thoughtful framing. So now let's dive into the benefits and the challenging parts of AI and how it's enabling participatory design. So Damiano, you can get us in.
Thank you. Yes, so I'm going to speak about participatory planning, which is a kind of a niche of urban planning and a niche of AI. Traditionally, what we do is that we involve citizens to sort of co-design cities. However, the way it actually happens is that we ask them feedback. We ask them feedback of projects that are already sort of on a later stage, kind of a nearly realized. What is the issue with this is that the participation process is more of a feedback process. So the people invited can only comment on it. And they actually do it with a medium that is a bit imbalanced. So designers can create images as the one on the left, while participants quite often, whether they use digital tools or printed tools, they can mostly express their own feelings and ideas using natural language, so text. So there is this medium imbalance. And the only way to sort of have people truly participating in co-design future of cities is that they sort of are able to replicate the same process that designers have. So what this process is basically ideation. So what AI does is that it helps participants to expand their imagination and test different ideas, but then evaluate their own ideas. So that's why in planning school and architecture school, we learn how to sketch, because then we are able very quickly to understand if it is a good or a bad idea in a given place. And the evaluation, I would say, is the most important part of the process. And then eventual deliberation. So a decision has to be taken. So this, what we've been basically building for the past like 5 to 6 years, it's a platform and a method to make this process happen within a workshop setting. I'm going to show you some example. This was the very first one. And the idea here is that you have a street, square, a neighborhood. You invite citizens, stakeholders, also investors as well, and shop owners. And together also with the specialists, they can co-design the urban space with AI, so that then the architects and the engineers involved in the actual design and construction process, they know sort of what are the needs and what are the ideas that came from the bottom up, so from the citizens themselves. This also is actually one of the best cases award from the EU. So the city of Helsinki, where this first workshop was hosted, won this kind of prize. But the point of AI is that it helps us to use the collective intelligence to reimagine the future of cities. But where is the intelligence in this collective intelligence? It's actually in that sort of way to add serendipity to the process once that you're able to visualize those images. What do I mean by that? This is an example of what the participants were doing, because what happened is that out of these 50 plus people that were there, basically the majority wanted to see bike lanes. As soon as they started to use the AI to visualize the bike lanes, they noticed immediately that, oh, actually, if we build a bike lane, we are going to destroy this beautiful cobblestone from the 18th century. And by doing that, we're also going to in some sense, remove this feeling of, old town, this kind of historic layer that the city has. So what happened is that this one person actually that was the first one to say this out loud made basically other people change their mind. So this is where the power really is in collective intelligence, is to then create new ideas. One of the other street, because this was part of, it's called the Summer Street Program. It's something the city of Helsinki did 4 years ago now, actually, 3 years ago. They were about 4 million euros to basically co-design and build summer streets, so pedestrian and bike-friendly streets. One of the streets was done without UrbanistAI, so citizens could not see what would be the impact of the bike lane. So eventually what most people wanted was the bike lane, so that was built. After it was built, actually people didn't like it. And indeed, what people felt is that it ruined sort of the historic layer of the city. So then the city had to spend, again, hundreds of thousands of euros to sort of remove it back. So you did this kind of back and forth. So this process actually has been applied to over 80 projects from 25 different countries. So we've been working with cities, with ministries, with also with kind of local citizens associations and universities. So to deploy this method and this platform basically across the world. And I'm going to show you some interesting examples, or at least some that I like. This one was done also in the city of Munich. And the idea exactly is that before you actually build a street, or before you actually plan kind of a big budget to sort of remake a street or to build public space, you can create prototypes. So instead of making a pilot project, do a project prototype and do that with GenAI. So citizens were basically invited to reimagine the street during a festival setting. Then their favorite they voted for their favorite scenario, which is the one on the left. And then the architecture students have built it, the one on the right. So this is a very nice way basically to ideate, but also prototype ideas and test them in real life. So this is how AI actually helps us to ideate, evaluate, and then eventually also experience those ideas. In Germany, there is City Lab Berlin that for 3 years now, they've been engaging citizens neighborhood by neighborhood. So they basically move around with the shipping container called Kiezlabor. They open it up in a public square or along a street. And all the passers-by are basically invited to co-design the very streets and square where this sort of a workshop truck is placed. Sometimes you really need to fill the space. So one thing that we do actually is that we can do this kind of walk and talk type of workshops where basically citizens, again, also stakeholders and investors of the projects can go to the place, take a photo with their phone, and then try their own ideas in the right place. Because sometimes you need to feel, okay, what is the temperature here? Is it usually windy? Is it cold? Do we need shading? These are things that you know only once you're there. And the city of Zurich actually, in 2024, so like a year ago, they've opened up this platform for the entire summer for all the citizens. So anybody in the city could just take photos and send ideas to the municipality. Sometimes you don't have a city yet, so you can use GenAI actually to create the design guidelines. And this was the case of Nusantara. We've been working with the indigenous community to co-create the master plan, basically, of the city that doesn't exist yet. Going towards the end with children, right? Because children are very it's very important to work with them in a way to build empathy, to understand the world from somebody else's perspective. But sometimes it's difficult for children if you're between 5 and 10 years old to express design ideas or wishes about cities. So the way we engage with children is that we first build a bit of AI proficiency. So we let them understand how the GenAI works when you draw objects. And then once that they understand, we basically give them a photograph. And when they have a photo, they can basically express ideas without the need to be articulated or to know specific language. So we can also have workshop with children of different backgrounds that speaks different languages, and they can still work together. And why this is important, of course, because to understand the future, we need to experience it. So there is no better way to do that with these kind of visual scenarios. Sometimes this future is also about to change. We have climate change and climate mitigation policies, and both are quite difficult to understand by children, also by adults. So we've been working quite a lot with the United Nations to create this kind of workshop where basically participants, when they take photos of urban environment or where they live or their homes, the GenAI actually simulates for them in real time how that place would look like if there would be a climate disaster scenario, so that you understand really what the impact is, but also what would be a climate mitigation scenario. So what if we implement those difficult to understand policies? And to go towards the end, basically, this works only if we do it both ways, bottom up and top down. So we've been working, of course, with citizens and citizens associations and local NGOs to bring their idea upwards. But for this process to actually be, if you want, like solid and accepted, we also need to push the governments to change, how they do participatory planning. So we've been working both on the top down and the bottom up. For instance, with the Prime Minister office in Dubai, where they've introduced participatory AI as a new method to engage citizens to build public spaces, or Singapore, and also like we have done this very interesting project again with the UNDP, where we have basically trained the mayors themselves to use Gen AI to sort of test their own policies. So like if they have some ideas, they can first like try them in the same way that citizens did before. This is sort of very briefly how it looks like. So you can basically select images from given place, and then you can, exactly in this case, test different ideas. What if this was pedestrian? What if this was a small urban park? And so on. And that's sort of how the conversation then gets started. That's it. So I think one learning that I wanted to give basically is that what we're seeing is that this democratic process eventually is not so much about building or doing what most people want, but discovering what we might want together in the future. Thank you so much.
Thank you so much, Damiano. That was very inspiring. It makes me want to go and draw my ideas. So before we move to the final speaker, I want to say, have a quick reminder that you have the opportunity to please put your questions in the Q&A box. So right after Mark, we will be opening the floor so you can spark the conversation. So let's move to Professor Dr. Mark Oelmann, who will tell us the lessons from water, but also how can we move from water and apply this in other spheres. Go ahead, Mark. Thank you.
Yeah, thanks a lot, Isabel, for inviting me, and well, all the best to all of you all over the world. Great to have you with us. And I'm now going to speak about using time series data with AI measures. So I think it's just a good extension after Damiano has just said something on planning and AI. You see that I'm having two logos here. So this is from my university. So I'm doing scientific research with a team of approximately 10 people. At the same time, we have a couple of products which we use for different purposes. As Isabel has put it, I've mainly started working with AI and water and wastewater. At the same time, I'd like to show you how or where the relevance is also for other public services. So let's start. Actually, well, we do have a bunch of data available, and my main question is how to best use them. So the question now first is when we start working with time series data, which problems do actually occur? And there are actually quite a number of problems. So the first one is we do have missing values which we want to fill up consistently. Secondly, AI is mainly able to find structures in data. So we do have these anomalies. However, in order to say if a certain anomaly is a problem or is not a problem, we do need to imply, or we need to also use human expertise to actually determine whether a certain anomaly is a problem or is not a problem. And due to my experiences, it's just very important to involve employees in the development of algorithms, because otherwise they kind of feel excluded. And while we need this trust and motivation of people to actually use the algorithms and the systems we are developing using AI. Thirdly, we have drifting data. This is quite a regular, normal problem, which we see that over a period of time, here it's 1.5 years, that a certain sensor is not delivering the correct data. And finally, we do have quite a number of other data problems. So for example, different or wrong physical units. If we combine different time series, then we, for example, have different time zones, or we have summer and winter time data. So this actually then leads to serious problems. However, kind of in validating data, this is actually nice to have, and it does give an indirect added value. So we are avoiding the garbage in, garbage out problem. The quality of data is improved, and this is actually leading to reliable algorithm outputs and a better system steering. However, I'm very much concerned also to see what additional added value we actually have, and we'll see that there are actually quite a number, and I would like to show them to you. So let's move on, and I'm showing you how to use these validation algorithms to find certain problems we would like to solve. So let us take a look at the following example. We have a river, and out of this river we are pumping water into a box next to the river, and in this box we have a certain number of sensors. And so this is kind of drawn out of a very recent project, and here we have the time series of the pH value, and we see that the pH value is going down now and then, and that this is marked by our algorithms as probably an anomaly, maybe a problem. So we see this pH value is falling, and we are discussing this with our partners, and they say, well, it actually is a problem if at the same time as the pH value is falling, the temperature is actually exceeding the daily cycle. If this is then actually happening, and we have certain other things to take into account, then we see the temperature in this box is getting higher, and the question is, when is this actually the case? Well, it is the case if we do have a pump constipation. So the main idea here is, if we are leveraging the relationship between different time series data, here the pH value data and the temperature data, we can formulate them in algorithms. We can then run these relationships in real time, and we can then detect right away operational problems, for example, a pump constipation. And this would then actually lead to the situation that we know right away that we need to send a certain person to this pump to actually ensure that the pump is not getting broken. There are quite a number of other examples I've brought. The second one is from wastewater treatment. Here we see this kind of drift. So the drift is getting dirty, and because it is getting dirty, we are putting in actually already quite a lot of oxygen. And if we put in too much oxygen into the water, we need too much energy. And in order to save energy, we formulate rules that we see this drift detection kind of right from the beginning. We also need to include the rainfall data. However, this would then actually lead to the situation that already within the very few days of a drift, we can inform the operational people that we need to clean the particular sensor. However, at the same time, there is an additional very important point, because if you see this period of time, this is about 15 months. Within these 15 months, we do not have a drift problem at all. So there wouldn't be any need for people to clean the sensor in between. However, here we have situations where it is very important to clean them quite regularly. And of course, in maintaining the functionality of the sensor, we have a much better allocation of our operational people when we do not have a fixed plan how to clean up sensors, but to send people to the sensor when it's actually needed. A third example I've brought, this is from actually water supply networks. Here again, we have a sensor drift. However, here on the right-hand side, what we do have is we have a line damage. This is the normal sign how we actually detect line damages in our water supply networks. So here we have the pressure time series data from the different zones in a water network, and we can see right away where actually a line damage is taking place. What we are now working on with a particular focus on water and wastewater is that we are working together with these companies or also public institutions within municipalities. And the main question is, well, first question is, what kind of time series data do you regularly use? And then actually put them into a framework, and to always show, well, in which time series we currently do have problems and where we need to come up with actionable insights and to trigger next steps. These were some examples from water and wastewater. However, if we kind of sum up, we mainly always have two steps. First of all, we are cooperating with a partner, and we do data analysis and the development of the real-time algorithm design. However, secondly, we can then afterwards also do forecasting. So, for example, here to show the probability of discharge values. So we have our wastewater company is allowed to discharge a certain amount of wastewater. However, if it's not able to fulfill these discharge values, it really gets into serious trouble. So our focus is, well, how do we actually forecast the probability that these discharge values cannot be kept any longer? And this is important because if this probability rises above a certain percentage, then we actually can put in further oxygen. What does this all imply for maybe other public services? In my point of view, there are many possibilities to actually use these approaches also for other public services. So, for example, if we take a look at transportation systems, we have these issues of traffic flow predictions, congestion management. We have the question of predictive maintenance for vehicles and infrastructure. We have maybe the issue to find accident hotspots over time. If we move to other areas, for example, environmental services, we might have the question of air quality monitoring and pollution forecasting. We might have the question of waste generation patterns and thus a collection optimization. We might turn into healthcare services, and we might think about hospital bed occupancy forecasting, or maybe medication inventory management. All these topics always start with this issue of formulating algorithms, then using them in real time, but then as well having forecast thereafter. Or let's think about public safety, so crime pattern analysis, hotspot predictions, maybe also staffing optimization for police and fire departments, or finally issues in social services, for example, unemployment benefit claim forecasting or social service utilization patterns. These are all issues where we can actually apply the mechanisms we've developed also to other topics, and the overall approach is always the same. So this has been my input now. Thank you very much for your attention. In case you might run into any questions thereafter, please do not hesitate to contact me. We have a quite international team, so we might be able to start certain projects also with people who might be particularly suitable for your context. And well, that's about it. And I'm happy, Isabel, to hand back to you.
Thank you, Mark. This was really interesting and a great way to close. So we want to open up now for questions, but let's start first with asking a question to the public, which is, what is the most promising opportunity AI can bring to cities in the next 10 years? What do you think? And we're giving 4 options here in the chat. So if you can just answer that question, and then we can, in parallel, move to the questions that we have. So I have some of the questions here. So if let's start with Damiano. The people are asking, what kind of institutional capacity or skills do local governments need to adopt or co-design AI tools? And are there any free access tools for cities or NGOs to start this journey?
Yeah, so well, of course, I was showing you UrbanistAI, which is the tool that we have designed. But of course, you can also, for internal discussion, you can also try different, Gen AI models that, like, you have DALL-E, you have Stable Diffusion. It's just that with UrbanistAI, you also have the voting, and it's designed just for participatory design, let's say. And for what the capacity is needed, actually, what we generally do is that we are not running the workshop. So this 80+ project that you have seen there, that I talked about, they're usually led by local institutions, either if they're cities or local NGOs. So the way it usually works is that we have this kind of a half-day boot camp. For some organizations, we maybe do it even once a month, but not much, to be honest. Basically, what's needed is the willingness to do it, let's say.
Great. We have a question for you, Somesh, and I think it's right on the line of your worry of human, which is, what safeguards, reviews, or processes are more effective in preventing bias when cities use AI to deliver services or make decisions? You're on mute.
Yeah, it's a very relevant question. So thank you very much. See, you would see it anywhere. Like the benefits of AI are so attractive that we do not think, we do not question, and we just adopt it, right? So it's so much attractive, and there is a point in it. But I agree with you. It becomes very sensitive when it's in the city services, because it makes all our population vulnerable to the bias if it contains. And we have heard about real life examples that a person was identified, the face recognition system identified a person as a criminal and was not allowed to board. And this is common. There are more cases about it. The only way I see at this moment is not to trust this AI so much fully. Do not public services decision making should not be taken fully on AI decisions. It's one of the sources, but it should be cross-checked still with the human sources, because not that I've come across so far that there is a AI algorithm without bias or without error, or there is no scope of error, and people are losing lives because of these kinds of errors. So great question. No quick solution. I would say strategically just slow down. Like AI, it is likable, but just being attracted to its magics, shouldn't trust it fully. Humans should still keep the final decision in their own hands. So that's my opinion.
Thank you so much. And Mark, we have like a double question for you. Two in one, which is, can we use AI for data analysis and projection of disasters or climate change impact? And what is your approach to balancing AI and local knowledge, especially in informal or politically sensitive contexts?
Well, first, yes, absolutely. If problems in a certain city arise from climate change, as an example, for example, we have droughts, and we have certain questions how to best use energy, for example, in this particular circumstances, or how to use water in case we have water shortages. Then we can use AI to come up with these algorithms and to help us getting along with the situation. This is this kind AI then is kind of made for helping us getting along with this situation. The second question is, I pointed out that it does make a lot of sense to use the knowledge of the people, and in my point of view, we need to see what actually AI is able to do, and where AI actually does not help anymore. And I think this kind of division of labor really is that AI is a superpower in order, for example, to find certain structures in my area in time series. However, in order to evaluate if a particular structure we find in the data is a problem or is not a problem, we actually need the know-how of the people to determine and to say, well, this is a problem or this is not a problem. So it's in order to actually use the whole strength of AI, we do need the particular knowledge of the people. And but having said this is not the only reason. AI comes along with a lot of fear and anger, and people just are afraid for losing a job, or for the need to just have their jobs totally changed. And so it does make sense to show them what actually AI is able to do. And so by including the people, we ensure that the various people are not afraid any longer, but that they are able to see how AI is actually able to help. And the question you've just raised, Isabel, also tackled the point of politically sensitive questions. In my point of view, this is even more focusing on the situation that we need to include people in determining how to use AI and where not to use AI. So I actually think we have tremendous opportunities with AI, but we also need to see where this actually comes to an end, and where what we're actually proposing is just ridiculous, because AI for itself, in many circumstances, is rather a tool than an individual solution maker.
Thank you, Mark. I will just put two questions. Any of you can answer it. We're 4 minutes away, so I think just one or two can answer, and you can pick the question you want to answer. So the first one, I think, goes in line with what, Mark, you were saying about how sometimes AI comes with fear and also anger. So how do cities gain support from public employees that perhaps are in that anger or fear? for these AI solutions. But also the second question would be, how do we make sure that the AI technologies that are being developed can help cities prioritize equity, transparency, and accountability? So we're not yet again affecting historically underserved communities. So who wants to go?
Well, I can share my opinion. Like, these are again great questions, right concerns. I think we should acknowledge this fear or concern is real, and we shouldn't ignore this concern. We are giving a lot of data, a lot of information, which is now coming into AI, which uses models which is not explainable. And somebody was also writing correctly in the chat, it just flashed up on my screen. There is no regulatory framework. You would see, and I'm also studying some real cases of conflict where we do not have a regulation which attributes blame to artificial intelligence. The human who has that device becomes the blame owner. So you are blamed for something which you're punished rather for something which you didn't do. So I think what I see, my opinion, please everyone else do share your opinion. I would not immediately give my most critical decisions completely on AI outputs. I would keep human supervisor on AI outputs. I would also adopt it carefully. By that I mean AI applications which governments adopt. We shouldn't adopt it for everything or every service which AI is applicable for, but we should adopt it looking at the impacts of the decision taken by AI. What if it goes wrong? For example, giving housing loan on social score. What if there was a bias on calculating your social score and people are excluded from the service? So the carefulness comes in trying to know the impact with scenarios. What if this goes wrong? So please maintain the human supervisor still to approve AI results and adopt AI, looking into the impact, how bad and how widespread it can be. Maybe a AI application is very attractive, but it may come with serious impact. So I would not adopt it in public services. That's my opinion.
Thank you so much, Somesh. Well said. And I think from a resilience perspective, we would be always taking into account the interconnectedness of every action we make and the impact it can have. So with that, I would say a big thank you to you and all the participants, but also Mark, Damiano. Thank you for having this amazing conversation with us. Do remember, you can check out our website so you can access the recording and the summary of this session, so you can share it with your colleagues. And stay tuned for the next session of CFL that will be focused on urban heat. Thank you so much and have a lovely day, night, or afternoon.
Thanks, everyone. Thanks.
Bye.
Bye.
Bye. Bye to everyone.